In this video, we want to graph the quadratic inequality y is less than negative x squared minus 6. So we're basically looking for all of the ordered pairs, all of the x and y values that are going to make this inequality true. And there are going to be an infinite number of points that will make the inequality true. So we're going to shade on the graph where all of those coordinates are. So to begin with, you can virtually ignore the inequality sign and just think about graphing the parabola y equals negative x squared minus 6. So we understand in this case that the parent function is going to be y equals x squared, which is a parabola. And then the negative out in front is going to cause a reflection over the x-axis. So the parabola will be opening down. And then we also have a shift down 6 because of this negative 6. So we're going to go ahead and go down 6. That will be our vertex. The parabola is going to open down, and there is not going to be a stretch or a compression. So this is a basic y equals x squared parabola. So from that vertex, I am traveling basically over 1 and down 1 in both directions, right and left. And then from that vertex, to get 2 more points from the vertex, if I go travel over to the right 2 squared would be 4. So if I go down 1, 2, 3, 4, that will land me right here. And then the same thing in the other direction. Just reminding you how to graph a basic parabola in case you have forgotten. So now I have 5 good points. Now, before I connect these with a solid line to make it a solid parabola, I do need to consider the inequality symbol because this is asking for y to be less than negative x squared minus 6, which means we are not going to include the points that actually lie on this parabola. And to show that, we are going to make the parabola dotted. So biggest mistake that I see made is students that just get in a little bit of a hurry and just want to connect the dots. But on an inequality, we have to look at that inequality. And because this is a less than, it's not less than or equal to, we're not going to include the points that actually lie on the parabola. As I mentioned before, there's an infinite number of coordinates that will make this inequality true. So now we need to think about the shading. And to shade and find where all of the solutions lie, we can use a test point. Now, a test point can be any point on the coordinate plane as long as it's not a point on the actual parabola. So in this case, 0, 0 is sitting right here, and it would be a great test point. 0 is a nice, easy number to plug in. So I'm going to test the point 0, 0, which just means that I'm going to plug 0, 0 in for both x and y in the original inequality. And we're going to see whether we get a true or a false statement. So I'm going to put a question mark on top of my inequality. Is 0 less than negative 0 squared minus 6? So that simplifies to the statement 0 is less than negative 6. And we're wondering if this is true or false. Is 0 smaller than negative 6? And it is not. So this is definitely a false statement. So what that means, since I got a false statement, that means that this coordinate that I tested, 0, 0, it is not going to be a solution to the inequality that we were given. So if 0, 0 is not a solution, then that means I do not want to include it in my shaded region. So because 0, 0 lies outside of this parabola, and it is not a solution, that means that the solutions must lie inside my parabola. So that's why I'm going to shade all of the coordinates that are inside the parabola because that's where the solutions must lie. So let me say that again. Whatever point that you test, if that point is a solution, then you want to shade over it. You want to include it in your shaded region. So in this case, 0, 0 is not a solution, so I do not want to include it. In fact, I'm going to erase that coordinate. I don't want to include it in my shaded region. I want to then shade on the other side of the parabola, which in this case would be inside the parabola. So there are an infinite number of coordinates that are in this shaded region. Just imagine all of these little ordered pairs, all of these x, y coordinates, they would all cause this inequality to be true. And that's why all infinite number of those coordinates are considered solutions.